Okay, so June 2011. Okay, so I've got the diagram. So this rod or plank AC is uniform, so that mass will act at the midpoint, length hinge to a vertical wall at A, so there's a hinge at A, there's hinge there, and I know I'm going to force it to the hinge, but I don't know what direction they are, so I'll give them two components, horizontal and vertical, supported by a light fixed rod BD, where D is on the wall and B is the midpoint of AC. Right, so B is the midpoint, and BD is a light rod. Okay, length of AD is 0.8. Boilings on the plank at C exerting a force of 20 newtons vertically downwards. Okay, so let's go back to the force now. Uniform plank, mass 15, length 1.2. So halfway along, that's 0.6 meters. I got the weight of 15 G. It's hinged to the wall, so if it's hinged to the wall, it has this reaction, which I give two components, horizontal and vertical components, X and Y. And I don't always put these in the right direction, but you know, at the end with the maths it'll come out. If I get a minus sign at the end, then I know I got the direction of X and Y incorrect. Right, so we've got plank supported by rod BD, where D is on the wall and B is the midpoint. I want the thrust in, right, so this isn't a string, this is a light rod, so it can have a tension or a thrust. Now it tells me it's a thrust. If it was a tension, you'd be pulling away from where it's connected to. Because it's thrust, it's going in the opposite direction, so it'll push towards the point of contact there. So there's a thrust T there in that direction. And we've got a force 20 newtons downwards at C. So there's my force diagram. Well, as we can see here, obviously this T is going in at an angle, and I got enough information in this triangle to calculate the angle. I'm just going to extend that force there, up there, so I'd rather see the T there really. That's the direction of the force, so it's easier to think of it coming up there than putting it back there. Okay, so I need this angle theta there, because vertically opposite angle, this angle will be theta there. Okay, so again, same with these questions, all the same thing. Because it's in equilibrium. Okay, I'm going to cross the T off there. Otherwise, I first think there's two of them. Okay, and forces up will equal forces down. Forces to the left will equal forces to the right. And then I'll be taking a moments equation as well. So that's 0.6. That's 0.6. Well, I need to deal with the angle. So just go on the triangle for distances. That's 0.6. That's 0.8. I'm calling that one theta. So what I got to do then is tan theta is 0.8 over 0.6. That will cancel down to tan theta is 4/3. So again, this is a 3, 4, 5 triangle. Okay, if I scale these up, okay, because it's only ratios, so that's 6 over 8 over 10, which comes back to 3, 4, 5. So sine theta is the opposite of the hypotenuse, that's 4/5, and cos theta will be the adjacent 3/5, adjacent of the hypotenuse. So there's the trig dealt with. Now in this T I need a component perpendicular and horizontal. So the horizontal one is T cos theta, the vertical one is T sin theta. So in equilibrium I'll deal with the vertical direction first of all. So I've got y plus T sin theta equals 15g plus 20. Going across, I've got x plus T cos theta equals 0, and that's show me really I got the direction of x in the wrong way. Mind, I'll just work it out and adjust afterwards. And then I'm going to take moments, and because there's an x and a y at A, the best place to take moments is about A. So I'll take moments about A. So clockwise moment will be 0.6 times 15g plus 1.2 times 20. It's 1.2 away from the point above which I'm taking moments, equals, and there's the anti-clockwise, 0.6 T sin theta. Okay, so I've worked out everything really. It's just a matter now. The first part A wants the thrust in the rod BD, so I want to calculate T. So from the third equation, so the third equation is going to give me then 0.6 times 15g plus 1.2 times 20 equals 0.6 times T times sin theta is 4/5. So all that is known, so that's 88.2 plus 24 equals 0.48 T. So 88.2 plus 24 over 0.48 is equal to T. So that gives me T is 233.75. Part B wants the magnitude and direction of the reaction at the NJ. So that means I need to find x and y, and then I need to use Pythagoras and trigonometry to get that. So I need to find x and y. So going from my first two equations.
Please can Katie Williams come to reception immediately. That's Katie Williams to reception. Thank you.
So from the first one, I've got y plus 233.75 sin theta, that's 4/5, equals 15g plus 20. So y is 15g plus 20 minus 233.75 times 4/5. So y is equal to minus 20 newtons. So as it turns out, the direction of y was incorrect as well. Second one gives me x plus 233.75 cos theta, which is 3/5, equals 0. So that gives me x is equal to minus 140.25. Right, so now we want the magnitude and direction of this hinge. So I put x to the right of my original diagram, so actually x is go in this direction to the left, 140.25. Y I put it going upwards, so now it's actually coming downwards with 20. So completing the rectangle, the diagonal gives me the magnitude of the resultant. So r squared will be 20 squared plus 140.25 squared. So that's the square root of that. So r is 141.67 newtons. And to get the direction, I find this angle here, theta. So tan theta is the opposite, which is 20 over the adjacent is 140.25. So theta and shift tan of that is 8.1 degrees, and it's below the horizontal. Okay, it's important you redraw the diagram interpreting those minus signs, because that diagram now is showing me exactly which direction that resultant is actually acting in.